we are going to find out the critical path, right? So the definition of the critical path is, or in other words, a critical path is consisting of the activities that with zero float or zero slack, right? We need to get the float of each activity. So in order to get the float for each activity, we need to use the forward pass and backward pass, right, to derive the early start, early finish, and late start, late finish. Okay. So based on the duration, right, duration of each activity, then we can have early start, early finish, right? For example, of course, A is the first activity, and the early start will be 0, right? And the duration of A is estimated as 3, so the early finish of A is 3. Right, then we have B and C is right after A, right? So the early start of first B and C is equal to the early finish of A, right? Therefore 3, and then plus the duration of these two activities, we have the early finish of these two activities. First of them are 10, right? Because duration is also the same. Okay? But one thing we need to be careful that, for example, for activity J, right, it has several predecessors. For example, I, F, H, and G, right? And suppose we have filled in the early start, early finish of these 4 activities, right? For example, I will early finish at 12, F will early finish at 33, and G will early finish at 26. Right, so the early start of this J must be the largest one or the latest one among the former activities. Right, there are 4 former activities, and the latest one is this one, 33. So we must select 33 and put it in early start of J. And then also plus the duration of J, we have 39. Right, and K also early start at 39 and early finish at 42. So this is only the first half, right? The second half is to use backward, derive late start, late finish. Okay, so the backward we begin with the last activity K. Okay, the late start of K and late finish of K must equal to the early start and early finish. Okay, so by backward we say the late start of K will equal to the late finish of J. Right, these two are equal. 39, verse 39. And minus this one, minus duration, we have the late start of J. Okay. And similar to the forward pass, for example, here, these two activities, right, they have the same predecessor B, right? So both I and F need to wait for activity B, then they can start. Right, so when we are going to fill in the late finish, late start, we can see the late start of I is 31 and late start of F is 22. So we say the late finish of the former activity must be the smaller one, right? The smaller one between these two. So the 1 and 28. So we select 28 as B's late finish. Okay, then minus the duration we have the late start of 21. Okay, the similar we can see here. The late start of say is 3 and late start of B is 21. So the late finish of A should be 3. Okay. So this is the rule for forward pass and backward pass to derive the late start, late finish, early start, early finish. And after that, we say we calculate float. So we have in this each node, right? We have early start, early finish, late finish, and late start. Then the float will equal to difference between these two, or the difference between these two. So the float will equal to late start minus early start. Okay. Or equal to late finish minus early finish. So this is the float. Okay. And the float has two possible results, right? One is two possible results. One is 0 and one is larger than 0. So we want to choose those activities with 0 float, right? So for float equal to 0, they are on the critical path. For float larger than 0, they are not on the critical path. Okay, so in this case, A, C, D, E, F, G, H, they are all on the critical path, right? And actually, there are several possible outcomes, right? Here, we have 3 critical paths based on this result. And the completion time of the whole project will be 42 weeks. Okay, this is what we have from this table. And next, remember that when we are doing the estimation, right, we use the rule that round it to the next integer. Okay, so what if we change another rule? For example, because we use this rule, we have several critical paths. So what if we make this estimate more accurate? So you can see if we rounded them to 1 decimal place, okay, the estimation now becomes more accurate, right? And based on this estimation, we can follow a similar way, right? We can draw a network diagram and do calculation for the early start, early finish, late start, late finish, and calculate the float and identify the critical activities. Okay, so here we find out the critical activities and identify the critical paths. So for a more accurate duration, we find there is only one critical path. It is A, C, D, E, F, G, K. Okay. So we could do it another way, right? Because we rounded the rule is now to 1 mass place. Then what if we rounded it to the nearest integer? So the nearest integer is if we have 4.5, then we round it to 5, but 4.4 we round it to 4. Okay, so this is the nearest integer. Okay, follow this rule, we have the result like this, and also we draw the diagram and calculate the informations and identify the critical paths. And we find under this rule there is only also only one critical path. So I show you this result because I want to show you that different rounded rule will lead to different results for your critical paths, right? I show 3 rounded rules for estimation and show 3 different results, right? In this 1 decimal place, we have a duration of 39.9 weeks, but for this we have 40 weeks. Okay, and our later discussion will based on this one. Okay, so we will discuss the later questions, for example, the probability, the crashing will be based on this one, rounded to the nearest integer. Okay, and only with 1 critical path. So we're back to our question. So they want to know what is the project without any crashing? What is the cost for the project without any crashing? And one thing to note here is we need to calculate, we need to sum up all the activities cost rather than only the critical activities. Okay. We also need to sum up the non-critical activities cost here. And the second question is the probability that the project could be completed in 35 weeks. So for this question, we first need to know, remember that we have figured out what is the critical path, right? And the next one we need to know is, so the time for the critical path, the expected time for the critical path, we also know is 40 weeks. And another thing we need to know is the variance of the critical path, right? Because for any random things, it has two critical characteristics. One is the expected, one is the expectation, and one is the variance, right? So another thing we need to do is to calculate the variance of the critical path. Okay, so here we just need to sum up, right, all the variances of the activities on the critical path, and we have the result 7.17. So this is the variance of the critical path. The next is to derive the standard deviation. So the standard deviation just equal to the root of this variance, right? So the root of this variance is the standard deviation, okay? So after this, we need to figure out, calculate this z, okay? So this z will equal to 35 minus 40. So the 35 is our target, right? Completed this within 35 weeks. And 40 is the expected duration of the project for the weeks. And divided by the standard deviation. Okay, then we have this z equal to minus 1.87. Okay, and so for the standard normal distribution, I can draw a figure of this distribution. Just like this is a standard normal distribution. Right, and this is z. Okay, so now we have a z of minus 1.87. Okay, here minus 1.87. And actually, the probability, okay, the probability of the completion time will smaller or equal to 35 weeks will be this one, right? The area of this, right? This is what the standard normal deviation, normal distribution tells us. Okay, because based on this 5, we calculate this z equal to minus 1.87. So the probability must be this, the area of this one. But in the exam, at the end of every exam paper, you will have a standard normal table, okay, like this. So usually based on this table to find out the probability corresponding to any z. But we will find that the z here are all positive. So we need to make some transformation. Okay. So because this is symmetry, right? So we just need to find out this one, right? Without the negative one, the positive one. And this one, we could base on this one to find out the probability from this table, right? So for example, 1.87, here we can find out 1.87 is this one, right? This one. 0.87 0.9683. So the meaning for this one is the square of this. Okay. The red one is what we find. Okay. Due to the symmetry of the normal distribution. So 1 minus this one is this one, right? And this are equivalent, right? They are equal to each other. So we find out z equal to 1.87 will corresponding to a probability of this one, right? So our probability of the time is smaller than 35 weeks or equal to 1 minus this one. So this is our the project could be completed within 35 weeks will be this one. Okay. So 1 minus this. So from this we say the project could be completed within the target only with a probability of like 3%. So it seems that it's impossible to achieve the initial target of this firm, right? So they must consider to crash certain activities for this project, right? So next step is for crash. So when we are going to, or when we are considering crashing a project, the first one we need to do is, so the black one is what given by the case material, and what we need to calculate is the slope, okay, the slope of each activity. And here we say this NA means these two activities, A and I, they cannot be crashed. Okay, because the estimated duration equal to the crash time. Okay, this is the first step we need to do. And when you are doing this slope, please pay attention to whether the activities could be partially crashed or not. Okay, if all of them could be partially crashed, then just calculate it directly. Okay, after this, we are going to select which activity to be crashed, right? So first, we put the weight the saves and also the activity slope here for each activity. And the first principle for crashing is to crash the activities on the critical path, right? So we make those activities on the critical path with red color, okay? So we must select activities with red color to be crashed. Okay, and another principle is we choose the cheapest one, right? So among all these red activities, the most cheap one is activity F, right? We only need to spend 3,000 to reduce the duration of F by 1 week. Okay, so our first option is crash F because it is the lowest cost and the completing time will reduce to 39 weeks. Okay, and now additional cost is 3,000. But one thing need to be noted that after we crash F, we find that the critical passes change. Okay, there are 2 more critical passes. So after we crash F from by 1 week, we have 2 more critical passes. Because initially we only have 1, but now we have 3 critical passes, and all the critical passes durations are 39 weeks, right? So we can see the figure here, 39 weeks, but 3 critical passes. So we can say after we question F, what is the next option? So among all the red activities, the cheapest one will be H, right? Only have a cost of 5,000. So should we crash H? Think about this question. Shall we crash activity H? Because now we have several critical passes, right? We need to ensure that after we crash one activity, all the critical passes will be reduced, right? Otherwise, the completion time of the project is not reduced, right? So suppose we now crash H by 1 week, and we will find that only 2 critical path duration reduced, right? Because we can see these 3 critical paths, H is only on these 2 critical passes, but not in the first one. So when we crash H by 1 week, these 2 passes duration reduced, but this one still remains 39 weeks. Right, so we should not crash H. Okay. So if we do not choose H to be crashed, next option may be J, K, D, E, right? Because all these 4 activities, their cost is 8,000. Right, so we need to select one among them. Right? So the next should be D or J, K or E. So which one should we select? We may have some selection rule, like we may select the earliest one. So the earliest one means the one is earliest in the past. Okay, or the most common one. Right, so among these 4 activities, D is the earliest one, the JK is the most common one. So either of these 2 options is fine when we have made a selection. And here we choose D because it is earliest activity. But you can also choose J, okay. But why we here choose D is not only because it is earliest, but also the other reason I will explain later. So suppose we choose D now to reduce 1 week, right? And we say reduce D for 1 week, the cost is 10,000. So now the total additional cost is 30,000, and the duration of the whole project is 38 weeks. Okay, and still there are 3 critical passes, right? The next one is still D, right? Because we say D could be crashed by 2 weeks, right? So another reason why we choose D is we can crash this one more time. Okay, so we first choose D. Then the additional cost increased to 23,000, right? And duration of the project becomes 37 weeks. Okay, then after D, we see the E becomes the earliest among the cheapest, right? So next, the current earliest among cheapest is E, so next one should be activity E. So we spend another 10,000 to reduce the duration of E by 1 week, and our duration becomes 36 weeks. The next one should be J, right? And the final one is K. So here is how we crash this project, right? After we crash J, actually we have achieved our target, right? 75 weeks. Okay, so this is how to crash this project. And the key here is you need to be attention to whether there is or whether there are more critical passes during the case, after we crash F, two more critical paths emerge, right? So back to our first thing is we choose select rounded rule, right? So if you use one decimal place or two decimal place, you will come with a different solution, right? Different rounded rule for estimation will come with different answers for the same question. So if in the exam it is not specified for the rule, so you just keep the consistency of your answer, okay? You use one decimal, then you use one decimal for the whole answer, okay? And here are some principles or rules we have applied when we are crashing, right? So the first, of course, is to select the activities on the critical path, right? And the second is we start with the lowest one, lowest cost. But when we are doing this step, not all the lowest cost can be crashed, right? Because in the case of several critical paths, the lowest cost cannot effectively reduce the computing time of the project. And the third is, if multiple lowest cost happens, like we have 4 activities have a cost of 10,000, right? So the tiebreaks can be, we can choose either the earliest one or the most common one. Okay. So these are general rules we can use when we are crashing the project. And remember that the field, it also has some other questions. So the first is, when the expected time for activity B is increased from 7 to 9 weeks, are there any effect on the whole project? Actually, there is no effect on the whole duration. The reason is, first, B is not on the critical path, right? And it has a buffer of 16 weeks. So the buffer here also can be regarded as the float or slack, right? So the slack of B is 16 weeks. So any time increased less than 16 weeks would not impact the project, right? But if B is, the duration of B is increased by, for example, 17 weeks, then B will on the critical path, right? Because the longest path changes. Okay. So here we only consider the chain of 2 weeks. It's much smaller than 16 weeks, so it does not have any impact on the project. And another scenario is the expect time for activity D is decreased to 7 weeks. Okay, in this case, because D has 0 float, right, which means D is on critical path. So the activity of the critical path, the duration will be decreased by 1 week. We can see the critical path will decrease by 1 week, and the completion time will be shortened. Okay. So this is all about the first case for the critical path and project crashing. And we may have 10 minutes break, and then we will go to our second